So the one thing that I would like to do then is just reintroduce myself. So let's see. So again, thank you for coming today. And my name is John Oakes, and I teach math at South Campus, and I've been there since what 2011. It seems like time flies, especially these days, right? So now let's see, let's go on. So if you wouldn't mind, then just maybe if you do have your slides on and you click the link in the chat, then you should get on the side or beneath it if you are on a tablet or a cell phone, a spot to type in your answer. But I'm just sort of wondering quickly what caused you to decide to come to this presentation today, or what interests you about the topic. And if you, for some reason, did not get the link, then feel free to put your answer in the Zoom chat also. So let's see. So let me show the responses on the screen for everyone. So there's one comment here about number puzzles. So there actually will be a lot of number puzzles in today's presentation, and then a lot of different fun facts, hopefully to help you stay sharp as well. So lots of ways to think of math and the world in different ways, and so that's what this is all about. So let me go on to the next one. So again, if you don't have the link in the slides, just feel free to follow along in the chat if you have a comment, and then also just feel free to just raise your hand or yell, and I'll make sure to answer every question, hopefully. So one thing that I always like to do is a little fun thing with math and a fun thing with numbers when I start any session like this, is just two truths and a lie. And I made this two truths and a lie up about email. So then one of these is actually a lie. So I'll read them here and then give you a little while to think about it. And then later on in the presentation, I'll have you enter which one you think is the lie. So number one, a study from the University of British Columbia found that people who reduced the number of times they checked email each day to 2 times were significantly less stressed. And number two, Bill Clinton claims to have only sent 2 emails as president. And number three, in 2015, it was estimated that the email distractions cost the US economy $650 $650 billion annually. All right, so a lot of cost there in lost revenue due to email distraction. So while you are thinking about which one might be the lie, I'll go ahead and again just share a little bit more about myself. So before the semester started, I went to the South Campus and created a welcome video for my students who would be learning all online this semester. So this is a little screenshot of what that looked like. That was sort of fun to do that, since I hadn't been on campus since what was it, like March, April, whenever we last actually got to go. And then I want to say, well, thank you for having me back, because I did give a presentation to SOAR back in 2015. So I'm happy that I was asked to come back today. And then outside of teaching at at Macomb, I also am the Midwest Vice President of AMATIC, the American Mathematical Association of Two-Year Colleges, and the webmaster for Todos Mathematics for All. And Todos is just Spanish for well, equity, and you can see also because of that, they're an equity, excellence, and social justice in mathematics organization. And then they are based in the Phoenix area, and so they do have a lot of Spanish speaking members as a result of their location. And then also I am the webmaster for KAN, the Korean American Adoptive Family Network. And so I do a lot of other things besides teaching, but I enjoy it, and it gives me a chance to get back to the mathematical community and the community that I am from, the Korean adoptee community. So one quick note, I guess, is that I really like tacos. It's one of my favorite foods. And so this is a combination dinner from a restaurant called Top Shelf in the Phoenix area. So I really like that real food there. And then I am a Pistons season ticket holder, and I have been missing the games, but thankfully the Pistons have come up with some virtual events for us, and you can see me maybe over on the left in the virtual seats there. So if you've been watching the NBA in the bubble at all, this is the same technology that they use to put the fans in the stands on TV. So it was sort of fun to be there. And then I do like beer to go along with my Pistons game. So this is actually a new beer that came out that I feel was sort of appropriate for the entire year, like just for what it's worth to me, since my mom was a nurse, especially healthcare heroes, I think sums up a lot of things. So now back to the 2 truths and a lie about email. So if you think that it's the lie is A, then put in A. If you think it's B, put in B, and if you think it's C, put in C. And again, if you don't have the slides up, you can put your answer in the chat as well. So let's see. So I think that it looks like C is the option that was picked as the lie, but it actually ends up being B, because Bill Clinton claimed to have only sent 1 email as president and not 2. So, I mean, that's a technicality of 1 number right there. So it does happen that if you're off by just 1, that 1 number does matter. Oh, actually, there were a few more votes. So yeah, and it seems like, no, oh yeah, somebody put B after I announced the answer. So that's okay also though. So let's see, let's move on then. So I'll try to have a few fun facts about numbers and math and things like that along the way today. So this is the image that started why I'm here today. So back in December of, it was actually 2018, I went to Korea, and I took a picture of this coffee mug here, and then I just looked at it and I thought, well, this looks really, really nice. And there's lots of mathematical things in the image here, like one of them being the symmetry of the design and the drink here, right? The right down the middle of the flower and the design. And so I decided that I would, because I like this idea of thinking about the pictures and thinking about the world around me mathematically, just start every one of my classes with a picture and then just ask the students in my classes, well, what type of mathematics do you see in this picture, and try to pick a picture that I've taken myself, so that would be more meaningful to me, and then have the students discuss it, and it would be a picture that hopefully would have some mathematics in it that would lead into the day's lesson. But because I want to use my own pictures, then it required me to have time to take a whole lot of pictures, and so that's how I end up taking a sabbatical to take pictures at mathematical museums and exhibits and displays around the world. So I would have this set of my own pictures to hopefully use as discussion starters in lessons in my classes. So this is one that I took here. So if you do have any thoughts about how you would use this sort of picture of just what might be just a drink that you would just have at a coffee shop to think about mathematics, then I like to hear what you have to say. But it looks like one person did put something in the comments in the slide. So what is the percentage of each liquid that shows on the surface of the cup, and what is the total volume of liquid in the cup? So I'll say that I have actually done this like this example with people in the past, and I don't think that I've actually had anyone say anything about the volume of liquid in the cup before. So I actually think that that's definitely something that that I'll be thinking about now. So so this is actually very interesting. How many times would you have to stir the drink before the image? And I'm guessing oh, excuse me. Yeah, it is one of those things where it would be interesting to me to also do that. And I know that I have actually had some students in some of my classes, sort of when we were studying the equation for heating and cooling, sort of take hot chocolate and figure out how long it would take for the marshmallows to melt in the hot chocolate. That was interesting. So there are lots of things that mathematics can be used for, or ways that you can think mathematically that you might think about like sometimes, but maybe not all of the time. So I'll go back to the picture for a moment, and I'll point out something that I think that is sort of interesting, and it's so I don't know how well you can see it, but it's sort of like the shadow of the saucer makes a Venn diagram pattern on the cup. And so that's something where I had somebody tell me that one time, and I'm like, I would never have really thought that way, but even looking in the shadows is important. And so one of the things that you'll notice as we go along here is that a lot of the pictures I show you will be these like sort of illusions of playing with light and distance and perspective, and it will be fun to just show you all of this. So I'm excited here. So I will also say that as part of this sabbatical project that I took all these pictures for, I needed some place to store the pictures, and I wanted some place for people to maybe talk about the pictures. And so I decided just to put them all on my website, and then I came up with a logo for the project, and just called it Everyday Math for Everyday People, and that's how this all started. So the first exhibit I went to was the Museum of Illusions in Toronto, and I actually was there for well to meet with a textbook publisher about a like a new math platform that was coming out that I wanted to learn more about. And then I found out by reading the newspaper while I was there in the hotel, well, there's a brand new math museum opening in Toronto. So I thought, well, this is timely. I'll go and I'll take pictures of things, and so here are some of what I think are the best ones. So you'll see that for a place that apparently just recently opened when I went there, it doesn't really look really that impressive on the outside. Just a little awning with a like a I don't know, like chained up door behind it, and then you have to walk a little bit farther down to get in even. And you'll see there that says that there are 70 plus illusions in the exhibit. So here are a few of them. One of them that was my favorite is the illusion where it does look like you are walking upside down on the ceiling, and then they had a maze of mirrors, and then the one on the, I'm trying to figure out why the one on the right just looks like that. I actually don't know why that's there. So so that globally goop there isn't supposed to be there, and I have no idea why that's there. So let's see. But this is another quick poll for you, though. Like, do you like puzzles? I know that there was already one comment that said that you were looking forward maybe to the number puzzles here. So if you like puzzles, then this next section will definitely be for you. So yeah, so I think that puzzles are pretty pretty popular. So let's see. So one popular puzzle that I use with my classes, especially like a discrete math classes, the Tower of Hanoi. And if you haven't heard of it, you have the most basic version of 3 discs stacked on one like spindle, and you have to move one disc to another spindle one at a time until all 3 end up in the same order on the last spindle. And so I thought, well, that's sort of interesting. And so I happened to find a picture of a similar setup at the museum. And so now I will be, when I'm teaching this class this semester, be using that example. But it's still, I think, something fun as a puzzle that you can there's a comment about the link. All right, I'll wait for the full comment to see what the problem might be. But the thing that I think is pretty interesting is just how, if you look at it, mathematics can be used to sort of show that there's probably some sort of algorithm or way to solve the problem of getting the 3 discs from one spindle to the other spindle in the same order the fastest. But a lot of people would just probably put the disc one at a time and then try to just try to just do it by trial and error, and that's fine too. But sometimes, you know, like having an algorithm with steps is interesting as well. Oh, so I see the problem in the chat. So code. So there's two ways you can join. So you can go also to joinpd.com and then type in the code ZINLGC. So hopefully that will work. So another puzzle that I saw, and I had seen the Tower of Hanoi before, but I hadn't seen this pyramid way puzzle before, and it was just trying to form a tetrahedron pyramid from the 3 pieces. So I took a picture of what it looked like when I walked up to the puzzle station, what it looked like when I walked away. So that's what a tetrahedron looks like. So just like a pyramid there, and then let's see. Then I think that a lot of people probably have heard of tangrams, because I know that I had some when I was growing up, and I still use them in my math for teachers classes. And this is just your puzzle that has been a square cut into 7 shapes, and those shapes are called tans, and then you try to form a specific shape. Like in this case, it was a square, and when all of the pieces cannot overlap. And so there ended up being my solution to the puzzle, and it probably took me longer than it probably should have, but that's okay too. And then there is sort of a similar version to that, but different, a broken heart puzzle. And I did manage to put the broken heart puzzle back together, but my biggest problem was that it was missing a piece and I didn't know it at the time. So I just stood there for a while doing it, and it just happened that it was a faulty puzzle. So if you sort of like think of that type of puzzle in a different way, like from a mathematical perspective, then anything can probably be cut up in some way that you would want to be able to put it back together at some point. So patterns and logic and things like that are one of the key parts of mathematics that I think that are that is overlooked too often. And then I will actually show you that when I got to the 5-piece pyramid, I gave up. So I'll tell you that I gave up when I got to the 5-piece pyramid. So I'm not going to show you the example of that being done, but I also gave up when I got to the Soma cube. And so you have, in this case, you can see like 7 wooden pieces consisting of smaller cubes, and then you try to form a 3 by 3 by 3 cube, and there are 240 different possible combinations. So you have to try to put it together in a way that it would fit back inside of that main cube box there. So if you have 240 different ways that the cubes could be put together, but then only one of them is going to be the right way to put it back in the original cube, this could take quite some time to do that. So even if you had an algorithm, like a mathematical algorithm of some sort to make sure that as you are trying different combinations out of those 240s, you don't repeat any of them, that would be good also. So let's see. Now, this is an interesting sort of, I guess, picture, and I guess I gave away in a bit of a way by saying it's a picture, but it's a close-up of a picture, and you can see that it's made up of different squares with different numbers in it. And I I kind of like that there was like a typewriter in here on the right, and then they had a mixed number like the 1340 and a half there, probably like a house number of some sort maybe. And then all of these, when you zoom out, end up being, and you can see it on the left here, end up being a picture of Albert Einstein. And so it just goes to show you that I think that this is a good example that mathematics like does compose a lot of things, and numbers do compose a lot of things. And then when you take all of these different numbers in little squares and piece them all together, you get Albert Einstein. So I thought that that was one of the really good pictures there. And then the quote by Albert Einstein is on the wall when you're leaving the museum. Reality is merely an illusion, albeit a very persistent one. So there we go. So that was sort of a good quote to leave the Museum of Illusions with. All right, so again, if you have any questions along the way, feel free to say something or put it in the chat. Otherwise, I'll just keep on going. But I have about I think I have 9 different places that I put slides for in this particular presentation. So we went through 1, so 8 more. Science City in Kansas City, Missouri. I actually was not originally planning on having this one as one of my stops, but I ended up being there for a math workshop, and so it worked out that I managed to make it to the Science City there. So here we are, of course, with Albert Einstein welcoming you. And then here is actually an exhibit that I thought was interesting just because of the fact that the bottom about Leonardo da Vinci, and da Vinci often mirrored his writing starting from the right and moving to the left. And some think that he wanted to keep the ink from smudging when he wrote left-handed, or hoped to make it harder for others to steal his ideas. So I do think that that's interesting, that his maybe perceived paranoia is actually part of the way that the brain and the eye actually works. So and this was in like a screenshot of, or like a static image of that fan moving and showing how the octolobe, that or is an occipital lobe. Yeah, I can't tell if it's me that I can't pronounce it, or if I can't actually see the word large enough on my screen to say it correctly. So one or the other, but hopefully you get the idea here. So this is another part of the Science City exhibit that I thought was interesting. There was a safe, and if you look through that little hole in the safe, then you are given this like sort of clue here. Why do the bars appear to stick out in the back but are indented in front? And so there's a little shelf that is in there, and then if you look through the hole in the safe, then it will end up looking like that cube there. And I think that when you try to draw a 3-dimensional diagram, we all maybe have learned the cube, first, and this was just interesting that a shelf just rotating around the turntable there, or the Lazy Susan in there, actually just ended up looking like a 3-dimensional cube. So I thought that was pretty interesting. And then, of course, you have your typical perspective example. So the one on the left about height versus width is the line on uh, the like the bottom, the horizontal line, the same length as the upright vertical line, and they are in the same sort of thing here with the perspective on the model here on the right. So lines and perspective and angles are one of the things that I tend to play with a lot when I draw things, or I paint things or anything like that, just because I feel like sometimes geometry is the overlooked part of mathematics, and it is important. And then this is actually just something fun. I don't actually know when I'll ever use this ever again, but this was actually like a illusion where you went in a restroom and looked at a mirror, and then when you looked in the mirror, it turned you into a skeleton in the mirror. So I said that, you know what, I have to take a picture of this just because I think it's fun, not that I'll actually ever have any use for it. And then finally, at the Science City Museum, we see on the left like a sketch of by MC Escher, and then some other like classic probably illusion where you look at once, you might see faces, and you look at twice and you might see something else. And so it's always interesting to ask like my students who are doing equations, like what would be the equation that would make that outline in a like a 3D model or something like that. But I will say though that of course this is a reproduction of a MC Escher work, but I was a little bit disappointed on my travels last year because I tried to go see some original MC Escher work, and I want to see his three-dimensional work and his tessellations and and everything that you may have heard that he's famous for. But on the National Gallery of or National Museum of Art's website, it said that they had an MC Escher exhibit, and so I went to Washington for the National Math Museum, National Math Festival last year, and I went into the the art gallery, and then they said, "Oh well, we hope that you didn't come here just for that, because we've taken all of his work off of exhibit because it's so fragile these days." So, so if you do see something original of his, just know it's something special, and you probably won't get to see it very often. So it is pretty amazing what like somebody can do to like draw in 3 dimensions and get those angles and everything like that correct. So oh, there we go. So again, if you have any questions, feel free to ask at any time. But I hope that you're at least enjoying a little bit of this. And so while I was in Kansas City, there was also a Stonehenge exhibit. So just out of curiosity, I'm wondering how many of you have been to Stonehenge? I actually haven't been. One of my former colleagues in the math department actually told me when she retired and uh, was just wishing everyone goodbye left and right, that that I should go to Europe and travel and do all of the things like that earlier in life if I can. And unfortunately, I haven't actually been to Stonehenge. It's one of the places I want to go, but the Kansas City traveling exhibit was pretty Good. All right. So we have three that have not been to Stonehenge. So then you might enjoy this as much as I did. So here is, and I think this one might be, yeah, this one is loading a little bit slower because it was actually a little bit higher quality, I think, because it came from the the uh the museum and not from me, like my camera. Not that my camera is bad or anything, but I don't want you thinking you're looking at low quality pictures. But why is it going so slowly? Well, in either case, is this maybe this is just a slow review of my face of it being at Stonehenge when it's really not. But I don't feel like I really want to wait any longer for it. But I thought it would speed up at some point. But this is actually the the place where the Stonehenge exhibit was, at the Grand Central Station, or the Union Station in Kansas City. So it's actually very nice just to be in there, in one of the historic train stations in the country that's still operating. And so, of course, you can see the little map here of where the exhibit was in Kansas City on the left bottom, and then where Stonehenge is in the Europe on the right. So here's a timeline of Stonehenge, and I think that this is all very interesting. And some of these here, like Stonehenge stage 1, I think, and a couple of them, I know that I'm going to show you the models that they had there in a minute, but I personally like just thinking about timelines and dates and times and things like that, and putting them in order and mapping things out like this. That's pretty mathematical in nature also. And I sort of think that at the middle where 0 would be, then I talk about, even though like it's to the left of 0, that doesn't mean time actually went negative and you can travel back in time. That's not what that means. And then things to the right are up until today. So this is always fairly like interesting to talk about time like that. And then if we move on here, yeah, this was one of the, I don't know if that was the exact picture, but I don't remember which one this was, because I think I cut it off this. I can't remember which one of the stages is which. That's why I can't remember which one this is. But you can see that this was the stage 1, I think. So it was really interesting to just think about how these models are made in the measurements that would have to be made to expand and reduce this model. So that's another aspect of all of this also. So here, I think this is an interesting little comment that I saw at the exhibit. So a lot of people sort of speculate how Stonehenge got there. Was it an observatory? Did astronomers use it? And so on and so forth. Like, was it a monument for religious reasons or whatever it might be? But you can see there that astronomers think that Stonehenge was built as a monument incorporating ideas about the cosmos and not as a precision tool for astronomical observation. So although you can go back and find out that a lot of great observations about the world and how the stars and the planets and everything move can be traced back to some of the work done there, it wasn't actually as precise as once thought. But you can see some of the tools that are there. And then I thought that this is really cool. The blue stone flakes from 2500 BCE, and the fact that they are still somewhat intact here, and they could bring them to a traveling exhibit is pretty amazing. Just to think about in time, like how many years ago that really was. So I really will be honest that I didn't really expect as much out of the Stonehenge exhibit as I actually got, but then I came to the end, and then they had the sign up there about all of the fields of study that are involved in discovering more about Stonehenge, all of the sciences and mathematical fields here. And so I know that mathematical modeling is mentioned right in the third line from the bottom of the list of all these fields of study. And I already know that one of the problems in my linear algebra class is about the the aging of pottery in aging of clay pots, and how would you know the age of one clay pot based off of its location where it was found relative to another clay pot. And so now when I talk about that topic in my classes, the next time I'm going to go ahead and mention some stuff about Stonehenge as well, because it's more of a real world example than just talking about generic clay pots. All right, so I thought that I would share this example also. And at the end of the Stonehenge exhibit, there were a lot of pictures and paintings and things like that of people making versions of Stonehenge out of everyday objects. And this banana one I thought was pretty interesting. So I thought, you know what, I'll take a picture of it. And if you think about it though, like that could be a challenge of anyone. Just take some everyday objects, like stack them in a certain way or cut them in a certain way. Can you get them to look like a version of Stonehenge? And lots and lots and lots of people have, and this banana version is one of them that I happen to like. So again, if you have any questions, always feel free to ask, but I'll continue to move on. And this one coming up next is the California Science Center. And this one was a real treat for me, and you'll see why in a second. But when you walk up to the Science Center, you'll see the aircraft there from the Air Force, and then the ones in the bottom right are what are hanging inside once you get inside and go up the escalator. And then there is a lot of space stuff. So it really is a museum that leans towards space more than some of the other museums I showed you. So this is an iron meteorite, and I thought that was really interesting. And then farther down it says about 4% of meteorites are iron, but they're easy to recognize. Now, here is an example for me, at least, of thinking about math every day. And I'm thinking, well, I would have no idea what they're talking about if I didn't understand percentages. And so I sort of thought, well, you know what, this is something that I could use with my students when I talk about percentages, and what does about 4% of meteorites are iron, but they're easy to recognize actually mean. And then this was the real treat for me. This is where the Endeavour space shuttle is at now. And if you haven't been to the California Science Center and you get a chance to go out there, this is what I would recommend seeing. And they're actually building a new hangar just to house it right now. So it's probably going to be even better in another year. And so just a little space trivia for you now, before I show you a few more pictures, but you should have like a dot on your screen if you're on the slide deck that you can drag to where you think Endeavour returned from its first flight. So was it May 16th, 1992 or July 9th, 1992? Excuse me. And there's no wrong answers, but I see there's one dot moving toward the July 9th so far. So I just put this here as a bit of trivia, but it actually is the, I feel like I see another dot trying to move, but it actually is the May 16th date because, oh, see, I was, this is why I was not a history major, but I think that it was the Columbia that came back on July 9th. And Endeavour came back on May 16th. So then you can see here that this is the nose cone from the Endeavour, and then you can get up close to it, but it says do not touch. But one thing that they will let you touch is the tires. So I did take the chance to touch the tires because I thought, well, all right, well, I'm not going to be able to jump up and actually touch the Endeavour when it's hanging from the ceiling in there. So I took the chance that I had to touch the tires. So they also have a chance for you to go out to the ET-94 external tank, and it's actually the last external tank still on Earth intact. And then let's see. Well, I was just going to point out, what was it called? Yeah, if you read this, it does talk about the new display of the Endeavour in the Samuel Ocean Air and Space Gallery, where the Endeavour and the tank and everything related to Endeavour will all be in one building now. And right now it's in like two separate buildings, and the tank is outside. So I'm sure that they are, quite happy to have it inside. So now, oh, I don't know why this is here. So there's me with the Endeavour, and then so I actually am thinking, where is it? So again, if you have any questions, feel free to ask. But I know that I had started with Toronto, and then the what was it? Kansas City, then the Stonehenge exhibit in Kansas City, and then California. So now I'm going to take you to Ireland through a few pictures of the Russell Library in Maynooth, Ireland. And so I was in Maynooth for the International Mathematics for the Future conference, which I had never been before, because of course I was like, oh, I don't know if I really want to go to an international math conference, but I took a risk, and I got a real treat of being able to go to the Russell Library at Maynooth University. And so I'm not going to really read too many of these facts, but I want to point out a couple of things. And of course, I'll share all of the slides after if you want to read more, which is sort of why I put all the handouts I collect and things like that in here. But the oldest item in the Russell Library collection is a stamp seal from ancient Mesopotamia dating from 3500 BC, and then the oldest printed book is dated 1470. So there's a lot of old stuff there. So they don't usually open the collections to people, but because we were there for an international math conference, they were a bit nice to us, especially since one of the people who is one of the curators of the library is also a mathematician in the math department at the university. So that helped a little bit. So you can look at the pictures and see the pictures of the museum here in the library here. But this is actually the mathematician from the Maynooth University holding up a piece of the book, like a scrap from one of the books. But this one actually, you know, I remember there's a reason why they showed us this one, but it had to do with the pull-out map, and they actually said that about like a year and a half before I was actually there for the visit, somebody had come to the museum to look at that map because they wanted to prove an old folktale incorrect, that a like a ship got off course and landed at a certain place, but then the issue is that if you use the map from that time, the ship would not have actually ended up where the claims say it did, based off of if you believe what today's map said. So this is all interesting also in terms of mathematical knowledge, like how do you look at the scale on a map, or things like that. And if you have an incorrect map, how far off will you be? And I just thought that was fascinating, that somebody wanted to prove an old folktale incorrect, so they went and looked for an old map to try to see what happened. So then, as I mentioned before, there are a lot of old tablets and other artifacts in the Russell Library collection. And so here is one on the left from like around 2100 to 2000 BC, and one on the right from about the same time frame. And so you can see like they were used for work and labor management, assigning workers to fields, messenger text. And so they did have to like write down their calculations or make their assignment somewhere. And that idea of making an assignment in itself is a mathematical idea. In the algorithms that you could use today to have a computer make an assignment of people to certain tasks is different than just how somebody would just like peck away at a tablet and have to do that back then. So I find that to be interesting. And then here is a book from Henry Briggs on arithmetic, and one from Copernicus on what was this one? One of Copernicus's book, but I know that we saw more than one, so I don't remember which one this is, because my Latin and especially is really bad, and which is really bad because I took 3 years of Latin classes in middle school, high school, way back when, and I don't remember too much of it. But this was interesting, a book from Galileo, and then one from Isaac Newton, which I thought was actually very interesting to see. And again, one of the rare things that you wouldn't see every day, like the MC Escher art. And so before I move on and tell you the next item, I'm just wondering, have you heard of Fermat's last theorem? And I'm just curious because there was a big movie made about it, I think like a BBC movie, and then a lot of like modern day adaptations of his story. and it wasn't actually proven until like, when was it? Sometime in the 1990s. So let's see. So one person said, yes, like it's a theorem that's more popular today because of the fact that it was proven at some point. But if I look here, it's just a basic theorem that says the equation for n greater than 2 of x to the n plus y to the n equals z to the n power has no solutions in terms of non-zero integers. But the interesting part is that Fermat wrote in the margin of a translation of Arithmetica, I have discovered a truly remarkable proof which this margin is too small to contain. Well, we saw that book, all right, at the Russell Library. So Fermat's, let's see, arithmetic book. All right, so I thought that was pretty interesting, like pretty great to see a book like that there in person. And so when I talk to my students about the Fermat's last theorem again, or if I watch that movie again, I'll think of it even more differently than before. So it was just really a pleasure to be able to get that close to the book from that long ago and take a picture of it, and then know that the theorem has been solved now or proven now. And so that was just one of my favorite moments of all of my time at the museum. So I know that we are running out of time, maybe for us to do this next thing. But I do want to give you at least a couple minutes to stretch if you need to, or ask a question if you need to. So does anyone have any questions so far, or any comments, or is there anything that you thought was interesting that you might want me to show again or say more about, or anything like that? Okay, so what was the movie? So the movie is called, the American version of it is called The Proof. And I do know that I had to get it off of BuzzFeed. So I've seen a lot of versions on YouTube or on the internet but the American version is called The Proof. So there are other movies called, there is one called Proof, but not called The Proof. So you have to be careful with the topics also. So let's see. And you know what, I should have put some sort of timer up here because I think it's only been like 2 or 3 minutes, but just if you did take a short stretch break or whatever it might be, and you come back, this is always something that I like to do, is just like just see how people are feeling after the break, because sometimes, like, if I'm thinking about things in a mathematical manner, I just sort of like keep on focusing on things, and I don't realize that I have lost track of the time or anything like that. So yeah, so okay, yeah, and actually I do like that I can see like the circles and things like that. I think that's sort of fun also. So I'll take a sip of coffee before the next bit here then. So let's see, let me just set up the next one then. And again, if you have any questions, feel free to ask. But as part of my trip to Maynooth, Ireland, to the International Mathematics for the Future conference, I also took the chance to go to Northern Ireland because oh, why not? Because you can say that you were in a different country just by crossing the little border there, and I didn't even notice it because I was in a bus when it happened, and so that was sort of interesting because the train was not working that day because it was being repaired, and so they took us on a train part of the way, then transferred us to a bus, and then back onto the train to go into Northern Ireland, and then I ended up losing my glasses in Belfast City Hall, and so at some point after like an hour of looking for them, I thought, well, I only have one day here, so I'm going to enjoy it and just buy new glasses when I get home. So while I was in Northern Ireland and Belfast, I went to Victoria Square. So it's just a shopping center, but on the inside, you can go up this elevator, or you can take the spiral steps. And I actually find the mathematics of the spiral staircase interesting in itself. But you can go up to the top, and then you can see that there's a platform that you can look out over the city, and they had a fake tree at the top for some reason. But the interesting part is the day I was there, Victoria Square had their Let's Play exhibit going on. So right in the middle of the what do you call it, the aisleway there, that they had this decal on the ground, and I thought, well, that looks sort of like Tetris or like Legos, or lots of fun things that would require some of the same logic and mathematical skills, like with those puzzles I showed earlier. And then I thought this was sort of interesting with the umbrellas hanging upside down, and I can think of all the questions that could be asked about what's the heaviest weight the umbrella could be before they would all fall down, or things like that. And then what I really thought was fun is that they had this painting of a Rubik's Cube here. So if you've ever wanted to solve a Rubik's Cube, just like with the Tower of Hanoi that I mentioned earlier, there's an algorithm for solving it, and you can just go ahead and go turn by turn, follow the steps, and then solve the Rubik's Cube. So for me, then of course I had to get my picture next to the painting on the wall, and you can see that it if you look at it, I'll go back because I'm not sure that it's clear from looking at the first picture that I showed that there's anything sticking out from the wall as much, at least. But then if you see, like, if look at my hand on the side of it, that there is a three-dimensional piece to that artwork right there. So that made it even more interesting for me, and made me think even more about perspective and angles and everything like that. So then after that, I did spend some time in Dublin, and I tried to go to Marcia's library, which I did make it in there, but but I put these pictures in here mainly so that you could have them if you wanted to later, because I actually could not take pictures in there, with one exception. I'll show you that in a minute, but that's why it was even a bigger treat to see the books from the Russell Library in Maynooth, because I got to see them and take pictures and get up close with them. But at Marcia's library, they're a little bit more cautious, and I did not know that in advance, but that's okay, because I still, got to see them, just not take pictures. So this whole brochure about some of the items that are in the library, you can see that there was a first edition of Isaac Newton's famous work on gravity in there, and other important pieces of work, or historical pieces at least. And then this is the one place where you can take pictures in the, the library there, and it's in the selfie corner, and you can see that they even put like a glass panel over that little bookcase right there behind me, and then they have a little frame there. So I apparently was the book thief, and because you weren't supposed to take pictures really anywhere else other than that, I was trying to take pictures on my own and things like that, and then a really nice couple said to me, well, I remember them, and I'm saying this because I thought it was just funny, and the guy, the husband, like came up and took a really close shot of me, and then the wife tapped him on the shoulder and said, "Don't take it like that. He probably wants a full body picture of him so that he remembers being in the library." So there you have it. There's my full body picture of myself in the library, because the guy's wife told him to do it. So so then again, if you have any questions, feel free to put them in the chat. But after my travels over to Ireland, I went to the Salvador Dali Museum in St. Petersburg, Florida. And so again, I told you how I like the spiral staircases. So there's a nice spiral staircase that is there, or you can actually take the elevator up, and then this is actually just part of the sculpture that keeps on going even above the stairs. So this is Dali painting one of his famous paintings. So if you actually don't know what it is, you might have to stand back a little bit from the screen, or look at the one panel down to the left of the woman's feet on the right side image, and you'll see more of what it might look like. So it's actually the portrait of Abraham Lincoln. And so this is sort of similar to me to how the image of Albert Einstein was drawn earlier, like a whole bunch of squares put together to make a bigger image, and this one happened to be at Abraham Lincoln. So again, I like this sort of art and how things like that are done. And Salvador Dali, if you don't know much about him, is known as one of the masters of deception, or masters of illusion, along with MC Escher and a lot of the other like people like that who are known for mathematical art of this sort of nature. So he had some sculptures out in the sculpture garden outside of the Dali Museum. And here on the right is actually one of the more famous ones, if you know his work, the one with the clock on the bench. And so I was going to tell you that my friend who was with me took a picture of me on the bench that I was going to show you, but I guess that one didn't make it in here either. But if you haven't been to the museum and you don't know, this is actually the golden ratio, like a or golden spiral on the right. And then this is an image from Donald and Mathemagic Land, like a pretty famous movie among mathematicians if you haven't seen it, just because I don't think that Walt Disney will ever do anything like this again after Hannah Montana and everything like that. So if you don't know about the golden ratio or the golden spiral, just out of curiosity, just a fun poll I thought I would ask. What is the approximate value of the golden ratio? Is it closer to the 2.718 or to the 1.68 1803? So, oh, let's see. That's okay. Like I see at least one response. So yeah, all right, yeah. And actually, I like that you can move the dot around, because if you're not sure, just put it right in the middle, and it would still be right. All right. So one of the famous places where this golden spiral and golden ratio comes in is in the Mona Lisa right there, or in the Eiffel Tower, or even in the Last Supper painting here. And um, so at the Dali Museum, outside of his garden, there is a big golden spiral on the ground here. And so I have some pictures zoomed in of it, and then zoomed in again, and you can see that, even zoomed in again, that you get something really close to what looks like the image that was in that Walt Disney film. But you can see like how quickly it spirals out. And so I thought that this was just really fun, especially as a mathematician who uh, likes these types of numbers, and even for someone who just has a curiosity about how something like this would be constructed. This could be fun, just to be there and see how fast the spiral would expand. All right, so there we go. There I am on the bench with the bench with the clock. So again, if you have any questions about anything, feel free to ask. But the next museum I went to was the Seocho Math Museum in Seoul, South Korea, and I went there separate from the trip where I showed you the coffee cup from, because I actually came back for a second time to take a Korean language class at Ewha University, and that was supposed to be part of my sabbatical plan also, was to take a language class, because I know that a lot of my students do know second languages, or are not native English speakers. And so I had never really learned much of any other languages fluently except for English, right? And so I was born in Seoul, and then I came to the United States, and so then I really just have known English fluently, and then had the Latin classes I mentioned to you. I took 3 years of Russian classes, but I really wanted to take a language class. But then I found out, well, since I'm here, and this was another one like the Kansas City Museum, like a since I'm here sort of deal. Let's see if there's a math museum, and there is. So here are a few images from the Seocho Math Museum. And actually, if you are ever in Seoul and you go to the Seocho Math Museum, a couple of pieces of advice. One is, it's a pretty big hike to get to it by subway, even though it's still in Seoul. It's not like in downtown tourist part of Seoul, and so it's like really big uphill climb from the subway up the hill to go around the corner to where it's at. That's why you saw me with, well, I'll show you in a second, but you'll see an iced coffee that I had because I just sweating because it was really hot last summer when I went. And the second piece of advice I give you is try to find a native that will call ahead for you and see when their hours actually are, because I went there and it looked like it was open, but I couldn't find any information about them on their website, and it ended up being closed. But I still saw some fun stuff, and I will share that. So this is what it looks like walking up to it. And then here was the cold drink that I told you about, but I thought this was a fun poster on the wall. Mathematician is a machine for turning coffee into theorems. So I have my iced coffee right here. So it's probably true that mathematicians probably drink a lot of coffee. But on a different note, out of a curiosity of wanting to know what you think, and just like as a fun fact, how many cups of coffee per day do South Koreans drink on average? Is it 1.64 cups, or is it 1.37 cups? And oh yeah, okay, so that would be the 1.37 cup. Yeah, it is 1.37 cups, and the 1.64 cups was actually, I think, the amount of coffee that Americans drank every day on average in 2001, I think. But now the most recent numbers say it's closer to 2 to 3 cups per day for Americans. So Americans drink more coffee than Koreans drink on average per day, at least. So like I said, even though I didn't get to go into the math museum itself, I went into the museum building, and they had some string art in the lobby of the math museum. And then going up the stairs to the math museum, they had like different pieces of information about Koch curves, snowflakes, piano curves, Hilbert curves, and Sierpinski carpets or Sierpinski triangles are popular also. And the Cantor set and the Menger what cubes or squares there, I think. So now I will show you that they have lots of other things that were part of the math exhibit just walking up to it. The like circle limits here that give you different designs here. And I think that even though this is in Korean, the description, that it is still just beautiful, I think, to look at the different designs and think about how mathematics could be used to construct these. And then what I found interesting is that they had mathematician superhero posters plastered up and down the walls. So this is a like a real treat for me also. And then out of nowhere, they also had this Egyptian stone that I from my understanding, from what I was able to read and what they told me, is that this is like some symbols for counting from the ancient times. So there was the door to the math museum. Once I got through all of their free displays in the lobby, that's on the left, the math museum on the left. And then I will say though that I did like look in there, and it was like 2 p.m. on a Tuesday. So I'm assuming that they were closed or something like that. But it looked like more of on the inside that they had a lot of spaces for people to like build things and like get your hands messy mathematically, like I've been talking about all afternoon, like with the puzzles and with the art and with the angles and the drawing and the perspective and all of that. That's the sort of space that they provide more in the museum, and they offer the other part of the exhibit freely and openly in the lobby and the hallways and the stairwell and things like that. So I'm not actually convinced that I missed too much, but I did enjoy the visit. So again, if you have any questions, feel free to ask. So I did end up somehow in Bismarck, North Dakota last fall for a math conference, and I was just substituting for somebody who was supposed to be at the conference and give a presentation and couldn't go. But I, of course, said, well, since I'm there, let's see if they have a math or science exhibit. And they did at the Gateway to Science. And so this was interesting that they had like a display on trusses and how triangles and squares are involved in strengthening all of these. So I thought that was a lot of fun to think about this. And of course, right, if you think way back, you probably were built a toothpick and marshmallow structure at some point, or know, someone who has, or you've encouraged kids or grandkids or whoever to build a marshmallow structure, whatever. And so like having this idea that triangles or squares like would maybe have different levels of sturdiness is an important mathematical concept. So this was interesting to me here, of a little space game here, and talking about data analysis. And we do a lot of data analysis and counting and numbering things all the time. So that was another thing that struck my eye as interesting. Then they had I'm showing you this one just for fun because I think air cannons are fun. What can I say? But just don't point it right at the at somebody, I guess. Now here are some more brain teasers. So you could set these up so that you could do them yourself. So like even if you just drew circles on a page and then tried to place the numbers 1 through 11 so that the sum of the 3 numbers in any straight line is 18, you could just do that anytime. And then 6 blocks in a box. So that's this one. I did try to stack them in the box, and I got that you're not going to see the completed one of this with the limited amount of time I had there. And then here's another one on perspective. Arrange the pieces so that there's one rider riding each horse correctly, right side and facing forward. And then this is one of those brain teasers that I absolutely don't like, with knots. And I don't know if you can see it, but the sign that I'm pointing to right behind me is by the hat rack is a chart of knots. So it's sort of intriguing to me that I don't like knot problems, but I'm intrigued by like the knots and how they're tied and how many times you tie each knot and things like that. So I find the mathematical beauty in just looking at the types of knots also. And then the 15 sticks, removing 6 to leave 10. So you place the sticks in the pattern, and you can see there, like you can cross, like one of these is a cross diagonally, one vertically, one horizontally through the middle of each of the three squares there. And then you could actually just like draw lines on your page and then erase 6 of the the sticks and see if you can get 10 left and go from there. Excuse me. So then outside of the museum, there were posters on the wall of women scientists and women mathematicians. I thought this was really cool also. So I will skip over the last couple of polls, since I know that I I don't know what the time limit is. So I think I am approaching it. So I want to make sure that you have time for questions. So but you can see here that these are a couple of more women scientists and women mathematicians. NASA had their Hidden Figures series of posters at the Science Center, the Gateway to Science also. And then just in terms of like how fun this was, I'm showing you again some just things I really enjoyed. Convex mirrors and concave mirrors. And if you look at what the concave mirror did to my mouth in my arms, it looks really, I look really distressed in that mirror. But I do know that I talked with my math for elementary teachers about convex and concave shapes and things like that. And so that this would be interesting to share at that time. So here is an asymmetry mirror and an S-bend mirror. And this was actually sort of disappointing to me that the museum had a timeline of the history of mathematics hanging from their ceiling, but they had a spot where I couldn't get the glare not to show on it. And I've been looking for this poster ever since, and I can't find it. So I think that they may have made it themselves, and they should have sold it in their gift shop, if you ask me. But in either case, it is actually like another example of how I like timelines. And then you can look here on the left here, and there's I don't know why, again, these didn't show up the way I wanted them to, but I'm going to show you one last thing. So if you look on the left, it says a sneak peek at the new gateway to science. And so one of the founding members of the Gateway to Science, like one of the founding donors who gave all the money to actually keep it up, like I found out, like died like only like less than 2 months or so before I went there, and I only found out because I stopped at this place called, and I don't know if you can see it, but it's called Buckstop Junction, and he carved these little blocks called exercise blocks and mental blocks, and then just sold them at the antique store, the Buckstop Junction in town, as a fundraiser for the Gateway to Science. And so I thought it was really cool that, like this guy was a lifetime donor to a science museum like this, and that I got a chance to, have something that he made, and that was kind of a heartwarming and special moment there. But I'll say that the new Gateway to Science, I'm sure, will definitely blow this one away, because they're already doing a fantastic job out there. But at the Buckstop Junction, if you ever go to Bismarck, I would go to the Buckstop Junction. It's like a mile or two away from the airport, and I didn't get to see the whole thing that day because they were having a wedding, but I went into the antique store, and they actually had some like mathematics books from the 1900s, and like early 1900s there. And the shop owner was like, you need to buy these, you need to buy these. And I really don't want to carry any books home. And then she's like, what, but you want to carry a book home from the 1920s? And I'm like, all right, you got me there. So they're in the the two books I bought are actually in the display case in the math department offices at South Campus. So that's why I don't have them here to show you on camera, or to even take pictures of them to put in the slides, because they're still on campus. But at the South Campus Math Department offices in G Building 400 level, there's a big display case of mathematics memorabilia. So whenever the campus reopens, or that building reopens, then I would encourage you to go in and take a look. The books I mentioned from the 1920s are there, like some old slide rules, like a whole bunch of old calculators, some like an Irish mathematical kit that I got when I was in Ireland, I bought to bring back for that display. So there's a whole lot of fun things in that display if you're just looking for like a historical perspective of mathematics, and not like this like art and calculations and all of that. So one last thing, because this was really cool, that when I was at the Detroit Zoo last year for the Wild Lights at the Detroit Zoo, if you did go, you hopefully you saw this, but this was a Haiba sculpture gallery that is a geometric exploration through light, shadow, and perception. And I don't know if I can play it here, but it is when you spin it, they turn, and I thought that was pretty fun to see that. So that's a different perspective of mathematics. Like, how would you maybe make a shape do that when you put it there and spin it? Or if you've ever seen those sort of cut out arts where you fold the paper and then cut it out and see what the snowflake might look like, it reminds me of that also. So a lot of fun in my opinion. So that, I think, is it. So I don't think I have anything else to say unless you have any questions, but I did want to leave some time for questions at the end, and I hope I didn't go too far over or anything like that. But my email address is there on the screen. There are even more pictures and more information about all of these museums and exhibits, and how I'm using the, oh yes, the like the pictures in my classes are in, and even if you're not curious about that part, just you could just look at them. So have I seen that origami folding techniques are being used for packing equipment going to Mars? No, I have not seen that. However, my craziest Mars story, or including like a related moon story, is that when I was in college, my well, I had this professor for a lot of classes, but he's really the the reason why I end up teaching in math to begin with. I think because he was very helpful. But Robert McCullough was actually one of my professors who was always into Mars and space and everything like that. And he actually was one of the people who NASA sort of worked with to grow tomato seeds that were brought back from the moon. And so like he always would tell us about the growth of these space tomatoes. So yeah, I haven't heard about the origami folding technique, but I think that sounds really interesting. But like I said, like everywhere you look, there's some sort of mathematics around us. And if it's something as simple as, yeah, let's contact NASA and see if they will let me be in charge of like the monitoring the growth of space tomatoes, I guess, like then you do it, like if that's something that you're interested in. And I always thought that was great that I had a professor who was like had that sort of enthusiasm for just everyday objects, because you wouldn't consider a tomato plant to be that exciting normally, but when you say it came from the moon seeds, then it becomes exciting. So that's how I perceive all of this when I say, like, my pictures came from Ireland, my pictures came from Korea, my pictures came from Florida or from Bismarck, and I have all these other stories along with them. I think that's what I think gives the mathematics that excitement and makes it so that it's relevant to everyone. So yeah, so are there any other questions or comments besides that one? But yeah, I will definitely look up that origami folding technique. All right, well, thank you again, everyone. And I guess I'll turn it back over to David, right? I think.
Yes. Well, John, thank you so much for presenting that for us and all the exciting places where, math is around us and available to see. So everyone, I want to thank you for joining us today for the start of our SOAR virtual semester. Usually after each session, we do the surveys. For the virtual semester, we're actually going to send out a survey at the end of the week covering the week that just transpired. So look for that coming up at the end of the week. And we hope you'll join us for some more SOAR classes. We have lots of exciting ones lined up the rest of this week and the next coming weeks. And John, I want to thank you so much for joining us today and presenting for us. I'll be in touch, but when I close out the meeting here, I think I will lose you as well. So I want to thank everyone.